It's our last section before test 3. Woohoo! Back to chapter 3 stuff. Last thing we're going to learn from chapter 3 is linear approximations and differentials. Linear approximations are super easy. It's just another way of saying the equation of the tangent line at a point. You already know how to do that, so yay, this will be good. So, if you look at a curve and its tangent line at a point, if you zoom in really close, they look almost exactly alike. So we're taking advantage of that fact by using the linear approximation as an approximation for the function itself. So you can settle for that easily computed linear value instead of that possibly incredibly complex to compute function value. So there it is. And that should be an A minus 1. I will go in and fix that before I post this for you guys. So, called the linear approximation or tangent line approximation at A. Let's look at this one because it's correct. The linearization of f at A. Now, let's look at an example and actually use that linear approximation or linearization at, in this case, A equals 1. That f of x is equal to the square root of x plus 3 at A equals 1. Well, we know how to do this. We learned this way back for test 1. If we want the equation of the tangent line, we need a point and we need a slope. So let's figure out first f of 1 would be the square root of 1 plus 3. So my ordered pair is the point 1, 2. F primed of x is going to be 1/2 x plus 3 to the minus 1/2 times the derivative of x plus 3, which is just 1, so easy peasy lemon squeezy. 1/2 times 1 over the square root of 1 plus 3, which is 4, so 1/2 times 1/2, which is 1/4. So my linearization, and I'll be consistent with the textbook here, L of x is equal to the slope, which is 1/4 times x minus the x coordinate. Now remember when we wrote down the equation of the tangent line, we did y minus the y coordinate. So this L of x is replacing the y, and we add the y coordinate to each side. Now let's simplify it a little bit because we're going to be plugging some numbers into it. 1/4 of x minus 1/4. And since I know I need a least common denominator, I just as well go ahead and get it. 2 is the same thing as 8/4. So 1/4 of x plus 7/4. Now we're asked to use this to approximate the number square root of 3.98 and square root of 4.05. So what I need to figure out is what input I need, f of what number is going to give me the square root of 3.98. So 3.98 is equal to x plus 3. So x is equal to 0.98. So f of 0.98 will give me the square root of 3.98, and I'm going to approximate that as the linearization evaluated at 0.98. That's a job for the calculator, so I'll plug it in and then come back and we'll compare answers. All right, I really did plug in the 0.98, and then I remembered that I had them on my PowerPoint, so I just scrolled forward, and we even get to look at the pretty picture here. The closer you are to 1, the better the estimate is. The further away you get, the less good the estimate is. Calculator could give us an approximation for the square root of 3.98 or square root of 4.05, but if we wanted it over an interval, we could say that that line is a good representation for that function over a small interval. So I'm not going to do any more examples. I expect that you should be able to find the equation of a